So, in the earlier lecture, I talked about sampling technique to measure the integral, to find out the integral of something, and I have used the Monte Carlo method. But now I will use the Monte Carlo method, but I will use the idea of variance reduction, right? So, in the earlier lecture, I have seen that the given function is a simple function and it do not largely vary from its average value. So means in the earlier lectures I have means if a function being integrated never differ much, never differ much from its average value, or variance is small, then we can use simple Monte Carlo method as I have discussed earlier. But if a function varies rapidly, then ordinary Monte Carlo method do not work. So in such a case, variance is large, then variance is reduced by choosing different function A, different function which is flatter function. So let us understand this diagrammatically. What does it mean? Say I am a function varying like this. So it's a given function. Let us call it as fx. And in place of this, I will use a flatter function and say, let me take different color. Yeah, it is a flatter function. Let us call it as gx. So it's x-axis and so y-axis, and I have taken points A and B because I am interested to find out the integral from A to B. So the given function is like this. So these are the function. This is fx and gx. So this is flatter function which I am using, and this is the given function. And the flatter function is chosen such that f of x minus g of x, its mod is less than epsilon, less than equal to epsilon, where epsilon is very small, such that integral of gx, it is equal to j. Now j can be evaluated using ordinary Monte Carlo method, and we can evaluate the integral f of x minus g of x. Also, we can also evaluate this integral. Therefore, integral a to b f of x dx, it can be written as integral of f of x minus g of x, the dx plus j. So thus a given integral can be evaluated using the flatter function, right? So thus using variance reduction technique, we can obtain better results. Thus, using variance reduction technique, we obtain better results, right? So this is all about this variance reduction technique. Then there is a very interesting method in which we will also decrease the variance by multiplying the given function by a weight function, and I will talk about that in the next lecture. And this process is known as important sampling. So that's all.